All right, everybody. Thanks for joining in. I'm gonna go ahead and get started here. I still see a few people trickling in, but I'm gonna get started with the housekeeping first. There's a Q&A section down below or on the top of your screen. So if you have any questions, go ahead and type them in there, and then Ryan and myself will get to those at the end of the webinar. This is not a NABCEP credited presentation, but still a lot to gain here. So both of our emails will be at the end if you need to get in touch with myself, Matt. I'm the trainer here at SimpliPhi Power, or we have Ryan here from MidNite Solar as well. And so I'm going to go ahead and get started and jump in here. Today, we're going to be doing the SimpliPhi Elite IQ training. This is how and why to combine Phi and MidNite products. So today we're going to talk a lot about the advantages that using Phi and MidNite products together offer, specifically MidNite's MPPT charge controllers and our standard Phi batteries. Now, these are analog batteries and really effective but simple charge controllers and combiners. We've both been around for quite some time now and really proven ourselves in this market. And I just want to detail some of the advantages of using these really simple to understand and just simple to install products in a market that's trending towards more and more complicated solutions like communications, which of course have their benefit, but aren't always necessary. So we'll talk about when you may want analog and when you may want communications. So this really just reminds me when we talk about this topic of when I was shopping around for my first car and everybody was telling me to get an older car because I could actually learn how to fix it on my own and it was easy to understand. You know, there's less points of failure and less costs added as you get a more complicated computer system within the car. Even, you know, fuel injectors added complexity and cost and another point of failure within the vehicle and system. So we're going to talk about really just getting back to the basics today and the advantages of these simple to understand and easy to install solutions that both SimpliPhi and MidNite offer. I'm going to get started with a company history and overview, where we've been, where we're going, and a timeline of our growth. So here at SimpliPhi, we were actually founded as OES Energy in 2010. We were leveraging a decade of IP-based lithium innovation. So we were really founded to solve a problem, and that was unsafe lithium chemistries, specifically in the mobile market, right? We were focusing on Hollywood filmmakers and making power packs for those Hollywood filmmakers' equipment that they could carry around with them and use during a shoot. And we were really just targeting, you know, a solution for the kind of disasters that continue to happen with lithium chemistries and still continue to happen. Now in 2011, we began to expand into other sectors, including military and emergency response. And the military really did not even want to use lithium batteries for their for the project that we were bidding on at the time. However, we were able to prove to them that lithium iron phosphate eliminated the thermal runaway and fire concerns that they were concerned about with lithium batteries. So even though they didn't want lithium batteries, we ended up being able to convince them that they were the way to go. Now we also introduced our Jenny units, for example, during that year for emergency response, and I still see a lot of those in use today. Now in 2013, we began expanding our product line, and in 2015 and 16, we relaunched as SimpliPhi Power. So now we're really focusing on the installer and customer when we create our products and solutions. And today we are ramping up manufacturing at our Ventura County location. This is where all of our batteries are actually manufactured now in Ventura County, California. So as I mentioned, we were founded to solve a problem which at the time was unsafe lithium chemistries. Now, however, the problem is really evolving. As time goes on, escalating energy costs are becoming more and more of a problem, not only here in the US, where we've seen rates rise over 15% in the last 10 years, but also in Europe and all over the world. And even in developing nations, you see the cost per kilowatt hour just skyrocket as people rely more and more on batteries and like little handheld AA batteries, for example. There's also failing infrastructure. So for just one example, transformers really were undersized from the get-go by the utility in a lot of places and just designed to overheat during the day and then cool down at night. And now when we're adding EV charging to a lot of these homes, transformers just aren't having enough time to cool down. And a lot of times they're just getting overloaded and overheating. Additionally, the need for decarbonization is growing. Over 150 cities in 13 states and 7 utilities now want to go net zero carbon without having a path to really meet that goal. So ultimately, what we hope to provide is a solution that provides access to safe, reliable, and affordable and sustainable power through distributed generation and storage. Our batteries are used in a variety of applications, not limited to peak shaving, time of use rates, and integrated solar plus storage. So peak shaving is, for example, using batteries to keep yourself from paying the utility an extra charge for using a high amount of power at any time. Even if it's a short amount of time, the charge can be pretty high. So you can cut off that excess power demand by supplying it with your own batteries. Time of use rates, we're seeing more and more in the industry just expanding. And what it allows you to do if you have batteries is simply buy power when it's the cheapest and then use it whenever you want instead of having to pay different rates at different times of the day. And of course, integrated solar plus storage. I think we all know this one, but basically the sun generates power in the middle of the day. However, most people aren't even home in the middle of the day, they're at work. So if you want to use solar power, you really need to be using it in the morning and at night when you're actually home. Then you're going to need batteries in order to save that PV energy for later. Cool. So through the background stuff, now let's talk about battery chemistry before we jump into specific MidNite and PHI solutions. So a quick comparison of different chemistries. Lithium iron phosphate is the only lithium chemistry that I know of that has no danger of thermal runaway and fire, no toxic elements, and it's actually landfill safe. There's no abusive mining practices involved in its supply chain because there's no cobalt in the battery, and lithium, iron, and phosphate are all really abundant. Additionally, there's no ventilation, cooling equipment, or safety monitoring equipment required. This is, again, really due to the lack of cobalt and the lack of toxic elements within the battery. Additionally, our batteries, lithium iron phosphate batteries, are able to withstand higher temperature range than most other lithium chemistries on the market. So they can operate up to 140 degrees Fahrenheit. So some specifications of our battery as well. I mentioned that we use only lithium iron phosphate chemistry. So let's talk about form factor. When we look at a cylindrical form factor, think about AA batteries. That's what the form factor looks like. So some advantages of this form factor are that it lasts a long time, it's really nice and sturdy, and it's got short circuit protection built in. It's also nice and compact for the amount of energy that you can fit into that space. Pouch cells are great, but they're often used for laptops. Unfortunately, they're a little bit more prone to swelling as temperature changes. Additionally, they can be punctured rather easily if, for example, you're in a mobile application. And prismatic cells are awesome. They're just a bit more bulky. So we have chosen cylindrical cells to be our form factor. They allow us to fit a lot of energy in a small package. They allow us the longest lifespan as far as cycle life goes, and they also just provide generally the best performance. So that's what we've chosen to be our form factor and chemistry. Those are kind of the building blocks. Lithium iron phosphate cylindrical cells are the building blocks of our batteries. Cool, so I'm going to do a quick overview of the products that we offer, and I'm just going to touch on the ones that are applicable today that are great with MidNite's products. And then I'm going to hand it off to Ryan to talk about MidNite's products as well. So this is our standard PHI battery, 3.8 kilowatt hour, offered in both 48 or 24 volt options. This is a simple parallel connection, and we're going to talk a little bit more about wiring later, so I'll just say that for now. It's a really modular and scalable solution. So this battery is 78 pounds, meaning one person can walk in and out of a job site with as many of these as they need to, taking a bunch of trips and build a giant system. So this is what's going to allow a guy like me to build a 300 kilowatt hour system if I want to, is by carrying in a 78-pound building block at a time. It's really designed as a drop-in lead acid replacement. However, now they're being used for all sorts of stuff, so there's no real limit to what you can use them for. I've seen them in mobile applications, even robotics, used for time of use, all sorts of different things. And each battery is going to have an integrated battery management system. We refer to it as a BMS. The BMS is going to keep the cells balanced and also provide some protection. So I'll talk about that a bit more too. It's also, each battery is going to have an integrated circuit breaker. This is a big advantage I see for installing our batteries. It's really nice to have a DC disconnect just right on the top of the battery. So if you're installing your battery and you need to make it not live, so no, 0 volt output at the terminals while you're installing it, you just flip the breaker off and then flip it back on when you're ready to go. So as I mentioned, all of our batteries have an integrated BMS and a breaker. The BMS is going to handle overcurrent protection, cell balancing, short circuit protection, and charge and discharge protection. So I'd like to just remind everybody that the BMS is not some magical wizard that's just going to allow you to plug your 48 volt DC battery into the wall and charge it up. The BMS does not modify the power that's being provided to it. It can't change the voltage or the amount of current. The BMS, all it really does is open the circuit or close the circuit. So that's something to keep in mind. Although there's built-in protection, in the battery, you still really need to design and install your system correctly. But we're going to show you why it's easy to design and install the system correctly using PHI batteries and MidNite charge controllers. So here's another product we offer, 12 volt and 24 volt battery. It's offered in 1.4 kilowatt hours, and it's got bare wire or Anderson power pole connection. So this is really more commonly used for mobile applications because it's smaller and it has these wires coming out of it. When you are in a mobile application, you're looking at a lot of vibration, and sometimes threaded terminals just aren't the right move. You wouldn't want to put a flat bus bar over threaded terminals and then have it bouncing around a bunch, for example. These batteries are about 33 pounds, again, making them really easy for one person to handle. And they also have an integrated BMS built in. And so with that, I'm going to hand it off to Ryan to talk a bit about MidNite Solar and their products.
No, thank you. And yeah, Ryan of MidNite Solar here. And we're going to talk a little bit about the products that we make that work well with SimpliPhi. Get a little back history on MidNite. We've been in the electronics industry for renewable energy for a long time. Most of our engineers and our founder come back from trace engineering and then through like Outback Power Systems and even Magnum Energy. You know, it's kind of like a family reunion when you walk through our building now and see some of the faces there. It's kind of cool. Some of the things we do are just power electronics, breaker boxes, surge suppression, combiner boxes, you know, that type of stuff. All of the balance of system equipment that you might need, you know, for your install. So if we go on to the next slide, if you would. So we're going to talk first about our combiner boxes, the 3 different models you might use, and then we'll talk about our charge controllers. This particular one here is probably our most common. We call it the MNLBC for lithium battery combiner. This one will combine up to 14 strings. It accepts up to 1/0 wire on the input. It's good for about 250 amps continuous. It is NEMA 3R rated if needed. It does have 5/16 output studs, comes with a 5-year warranty, and it is powder coated aluminum. So as you see in there, you have your your positive and negative bus bar. It's a pretty simple product. And when you're using the SimpliPhi battery with the built-in breaker and overcurrent on each battery cell, something like this is very elegant because you don't need to double down on your overcurrent protection, if you will. Just makes a nice clean install for a single inverter system. If you need more power, we'll talk, you know, about that upcoming. So if we go to the next slide. So why do you need a combiner? And this picture, I use this picture a lot in my presentations. Just like in your solar modules, you know, people overlook batteries a lot. They do stuff like this and don't really think about the power in that battery. But just like your solar module, if you've got more than one string of batteries, if something happens in a battery and it gangs up on a bunch of other batteries, things can melt, burn, catch on fire. You know, not the battery itself so much, but the cabling and stuff. You know, in a case like this, if that last battery on the left should short out, all the current's going to run back through that bus bar and try to feed that battery. And that's one reason why you need, you know, combiners and overcurrent protection. But the biggest reason you need a combiner box is you need to keep your cable lengths, you know, uniform and equal. So things charge correctly. If you look at this battery here, you can see they're feeding it in the middle, which, you know, from that respect is pretty decent. But that means that the 2 batteries in the middle are going to get most of the current, and the ones on the outskirts are going to get a little less current. So in an ideal world, you'd use a combiner box, and you make sure all your positive and negative cables are all the same length to run to that combiner box. And that's more and more important with, you know, today's batteries. I mean, it used to be when we did a lot of lead acid, we would tell you 1 string, maybe 2 strings of batteries max. We would never say, let's do 6 strings of batteries like you see here. But now with the lithium technologies and with the SimpliPhi battery, it's so easy to do multiple strings and expand as you need to expand. So you always want to look at that system and decide what you're going to do, where you think it's going to go in the future, and make sure you allow for that so that when you do add a couple more batteries, you know, it's easy to add into there. So we'll go on to the next combiner box. So this is another offering that we offer, which it's another nice solution. It's quite similar to the one you saw before. The only difference really is it's only good for 10 strings in, and it has a 250 amp breaker internally. So you can actually use that as a disconnect if say your SimpliPhi battery bank was 7 or 8 feet from your inverter and you wanted a single disconnect. You may have 8 SimpliPhi batteries, and instead of shutting off all 8 switches, this would give you that single point to disconnect. And it is a weatherproof box, just the same as the other one. and all the same characteristics, still powder coated aluminum, 5/16 output studs, etc. So, go on to the next slide. So then we get into probably our more common battery combiner box. The ones we just talked about are good for 250 amps. So, it's good for feeding a single inverter, maybe two small inverters. But if you're doing a larger scale system, this one is much more common. This is good for 1,000 amps continuous. The shunts are, the shunt is 1,000 amp, the bus bars are sized for 1,000 amps continuous. The box itself is powder coated steel. It has 12 knockouts, 6 on either side for breakers. So you can put in anything from a 5 amp to a 250 amp breaker into this box in multiples up to 12. So you could use, for example, our remote trip breakers if you needed to trip the breakers from an external, place. A common issue that we see, or a common need for that, is when the batteries and everything's in a power room and somebody wants to disconnect from outside the room. They don't want to have to go in the room to do an emergency disconnect on something. So that's able. You're also able to put in battery breakers in here for, say, inverters if you needed them, if you didn't have a breaker panel for the inverters. So this particular one comes in a couple models. It comes in a 1000/100, and what that means is it has a 1,000 amp, 100 millivolt shunt. Most people won't really care too much one way or the other on that. I think the SMA uses a 1000/50, whereas everything else, pretty much industry, uses the 1000-100 millivolt shunt. So if you're going to hook the shunt up to your inverter or some kind of battery monitor, you're going to want to check with the manufacturer on that to see. Like if you're using a classic and you want to use a Whiz-Bang Junior, you'd need the 1100. So, that's something to keep in mind. You can get the optional second bus bar, which is shown on the left. So if you were hooking this up to, say, a single Snyder inverter or Outback inverter, you might not need that optional bus bar. But if you were going to hook up, say, 4 inverters to 10 SimpliPhi batteries, then you would put that optional negative bus bar in there for your inverters to land on one side of the shunt and, the SimpliPhis to land on the other, so that you can use the shunt still to monitor. Other than that, it's indoor rated. It does come with a 5-year warranty, and we did mention it's powder coated steel. So that's kind of where we're at on that. It's a pretty simple box, as you can see. It's big. It's very big. The picture doesn't really lay it out there, but there's plenty of room to get you, 4-aught or 2-aught battery cables in there, the inverter, plenty of knockouts. So I think we'll go on to charge controllers now and, tell you what we do there. I'm not going to spend much time on our particular charge controllers because at the end of the day, they are an MPPT charge controller. They're easy to use, easy to program. There's a couple things that we have that I think set us a little bit apart, and we'll talk about those. But some of the more important things to know is understand the charging parameters that are required by your battery manufacturer. So what I mean by that is, we take calls all day long. Somebody will have a charge controller in the system, and they're plugging it all together, and they really don't know what to charge to. So, SimpliPhi has done a great job. They have an amazing white paper that will show you step by step how to program your MidNite Classic for their batteries. It's not really that big a deal to do that, but if you don't know those numbers and you just turn the equipment on, it's going to run at defaults, and most likely it's going to be, way off for what you need it to be. But some of the things that I mean by that is like the absorb time, for example, on a lithium, like the SimpliPhi, tends to be a lot lower than it would say on a lead acid. So if you just turn the classic on out of the box and just push your way through the setup screens and don't actually program it, it's going to give you a 2-hour absorb time. So that's something to keep in mind. Get the specs from SimpliPhi. When you got your classic, you power it up, it's going to walk you right through putting those specs in. The nice thing about both products is that they are very simple, hence the name. You have your absorb voltage, your absorb time, your float voltage, and that's really all you need to deal with for the most part. And there is some end amp settings that we can program in, but all of those things are going to be requested from the classic on power up and supplied by SimpliPhi in their white paper. So it's about 4 or 5 sets of buttons to push, and you're up and running with both products. So that's kind of nice. The other thing I want to point out, and this is not just a MidNite thing, I want to point this out across the board with all power electronics. Take a voltmeter and verify that you're getting what the controller sees. And what I mean by that is, like, when you get your Classic powered up, maybe it says 52.4 on the screen. But let's put a voltmeter on the terminals of the Classic and let's see if it agrees, to make sure that you don't have something out of calibration or out of spec. You know, I've seen, for example, I've seen Magnum inverters come out of the factory with a battery resistor that had them reading off by 4 volts on the battery voltage, 4 volts under too. So that's even worse, because then when you hook it up, you know, you end up overcharging by 4 volts. So that's really kind of one of those belt and suspenders things. But I always encourage the installers to put their voltmeter on everything, double check everything before they actually just let it go. You know, that's a big one. Most of the equipment can be recalibrated in the field if need be, but do check that. And as mentioned earlier, you know, the BMS is not there to babysit what we're doing. You know, the Classic is actually still in charge of what's going on. The BMS is just there as kind of that, you know, that study hall monitor, if you will. And if we get really out of line, that BMS is going to open up and say, okay, we're done. But you don't really want to be there. You don't want to do that. That's not intended for, you know, repetitive use or, you know, just normal behavior, because now you're shutting off your inverter as well. So those are things to keep in mind. The Whiz-Bang Junior, which I can't remember if I have a slide in here, but we will talk about that. It's shown on the right there, and it's a very simple device, one wire hookup to our charge controllers. One of the interesting things about that is that allows us to know true amperage into the battery. And what I mean by that, with most charge controllers, when you plug them in, they're only monitoring themselves. So if my Classic is putting out 80 amps, it's putting out 80 amps into the system. If the Snyder inverter is drawing 40 amps to power loads in my house, then the SimpliPhi is only getting 40 amps. So it's important to know what's actually going into the SimpliPhi, not just what's coming out of the charge controller. And that's a really nice thing to use, you know, to set up and use. The other thing that I'll point out is equalization settings. By default, you know, they'll be set low enough that it doesn't matter, but I always go in and check that. I always turn the equalize time to 0 and just make sure they're disabled. You know, it's one of those things where I've seen many situations where people will get in and push buttons in products, and you may have set equalize to disable, but you forgot to change the time. And if Harry, the homeowner, gets in and starts pushing buttons, you may end up with, you know, something that trips your BMS again. Temperature compensation is another one of those. Just don't even bother to plug in the battery temperature sensor. That's my rule of thumb. Don't even plug that in. But if you want to plug it in for other reasons, make sure you go in and disable the temperature compensation. Just set it down to 0 millivolts per degree C per cell. And that way you're not doing any compensation, because the SimpliPhi is not going to want you to compensate. And out of the box, most of our power electronics, like the MidNite or the Outback or the Snyder, the Morningstar, they're going to do compensation if you plug in the battery temperature sensor. And what I mean by that is, if a battery is colder than, say, 25 degrees C, it's going to start raising the voltage to compensate for that cold battery. And if we do that to the SimpliPhi, the BMS is going to have to open to prevent us from overcharging, which, you know, we don't want to do. So just disable that. We talked about the current limit in the Whiz-Bang Junior. So, you know, it's pretty straightforward, really. Go to the next slide. Yeah, so I guess that's the end of my slides.
Cool. Yeah, well, thanks so much for that overview. I really agree. The MidNite Classic is in charge there. You know, the BMS is just an extra line of defense. And I really like how you can not only disable temperature compensation by unplugging the temperature sensor, but also set it to 0 millivolts per degree C. Some of the charge controllers don't allow you to set it to 0, so it's really nice to have a little redundancy there. Or maybe you just want to monitor the temperatures and also turn off temperature compensation. So that's a nice added bonus. So as far as installing our products together, I just want to talk about ease of installation, scalability, and cost. So when we're talking about installing, it's really nice to know that both our products are scalable. There's really no limit to how many PHI batteries that you can parallel, and the same with the MidNite Classic charge controllers. Now, I would generally recommend 2 to 4 PHI batteries per MidNite charge controller because you can get a pretty high current output out of both. So you get C/2 for a PHI battery, so meaning you get about 37.5 amps continuous in or out of a 3.8 kilowatt hour 48 volt battery, and up to 96 amps DC per MidNite Classic. Now I think it's a little lower amperage for a 48 volt battery. Is that right, Ryan?
Yes, it's 84 amps on a 48 volt battery.
Perfect. So yeah, so it'd be a great combo for about 2 to 4 batteries, depending on how much solar you have per MidNite Classic. And now, also, both products are pretty versatile. So not only can they be used on or off grid, but also the Classic and PHI battery can be used with PV, wind, or hydro. You know, the battery is not really going to care where the power is coming from because the charge controller, regardless, is just going to provide it DC power just as it wants at the correct voltage. However, some charge controllers aren't able to handle wind or hydro, so that's awesome. That's super impressive that it's versatile enough to handle any of those. As far as the battery combiners, why those are nice is because, again, this allows you to flexibly size your system. So you can create a really large system. Specifically, this combiner box up top is probably best for a really large system. It's going to allow you to distribute power evenly, not only for charging, but also for discharging your battery bank. This is going to make sure that all your batteries are nice and balanced. And if you want to add a convenient DC disconnect to your system, and you have a system, I'd say 10 batteries or less, that combiner box at the bottom is perfect. We're actually going to see one of those installed here in a minute. And I really like that the combiner box up top as well has the option to add the remote trip breakers, as we've seen more and more jurisdictions kind of cracking down on the rapid shutdown installation equipment that you need to use, and where you have disconnects, you know, the option to add a remote trip breaker in that combiner box is a really nice option in case your jurisdiction comes back and says, hey, you need one of those. Additionally, having this extra DC disconnect, like Ryan said, it's going to make commissioning a bit easier if you've got 10 batteries instead of switching them all on and off and trying to kind of switch them all on at the same time. One thing we've seen is the Outback Radian has a very large capacitor inside of it. It has to be, you know, charged up before beginning. So if you've got 1 or 2 batteries on an Outback Radian, which you should not do, but let's just say you're turning on one battery at a time, sometimes that's just not enough to turn on the Radian's high current draw. The battery's BMS will actually trip due to it detecting a short circuit. And then the way to solve that really is just by turning on several batteries at once, and they can all share that startup current. The best way to do that is just with an extra DC disconnect like this one you see here in the combiner box. So you can turn all your batteries on, and then after you've done that, then you can turn on this breaker within the combiner box here. So I want to talk about our parallel wiring requirements. So as most of you know, we require that between the battery and the combiner, you have the same size, same length cable from each battery. Additionally, you could use a bus bar across all the battery terminals, and then from there take same size, same length cable from all bus bars to the combiner point, or even just land it directly on the inverter. What this does is it allows the batteries to balance very well. They're all going to be basically at the exact same voltage and have the same impedance between them and the inverter and charge controller. Additionally, we want to see these terminals tightened to 160 inch-pounds using a calibrated torque wrench. So here's what not to do. Do not use a socket wrench because you're not going to know when you've hit 160 inch-pounds. Now, it's not a really big deal if you don't tighten them quite tight enough. You might see a slight increase in resistance. Again, that's not ideal. It's not what we recommend, but I'd much rather see you under tighten than over tighten, and have actually seen somebody snap off a terminal because they used a socket wrench instead of a torque wrench. So make sure you pick up a torque wrench. Also, don't wire them terminal to terminal like this. Now, I realize that this is parallel wiring, but all these batteries are going to have a different impedance between the battery and the charge controller. For example, the charge controller is going to want to charge this battery more than it's going to want to charge this battery, for example. Same with the inverter. It's going to want to draw power from this battery first. An advantage, as we mentioned, of the MidNite charge controllers and the PHI batteries is that it's very easy to program and it's easy to understand what they need. So as Ryan mentioned, lithium batteries need a very small absorb time. You're able to set that to just 6 minutes in the MidNite Classic, which is perfect. Another thing I wanted to mention about the MidNite, and Ryan, you might hate me for this, but if there's ever a charge controller you were gonna program without looking at the manual, it's the Classic. Now, I'm not saying you should do that. I'm just saying it's so self-explanatory when you go through it. Also, Ryan's got this video here. It's, I'd say, 5 minutes or so, and he just explains, exactly how to program the controller. And you're just gonna reference our integration guide. All the settings are right here. That's what you're going to plug in as you're going through the menu. As we talked about temperature compensation, I just want to mention why temperature compensation is needed in some scenarios. For lead acid batteries, for example, temperature compensation is entirely necessary. Now, without it, when it's too warm, the battery is going to overcharge if you did not temperature compensate. And that's going to cause gassing. And then we're talking about lead acid batteries here. So also when it gets too cold, if you don't temperature compensate, your battery is going to undercharge and it's going to cause sulfation. Oh, excuse me. Didn't mean to jump forward there. But with SimpliPhi batteries, temperature compensation needs to be disabled. They really don't need temperature compensation. They're not really affected by the cold or hot weather all that much. In many lithium batteries, actually, it can be dangerous to charge at too high of a voltage. Now, luckily, the BMS is really going to take care of that, but it doesn't mean you can just leave temperature compensation on and rely on the BMS to handle the rest. You still need to set things up correctly. Now, as far as cost of ownership, we really want to look at the cost per kilowatt hour. And when you're looking at the cost per kilowatt hour, you're going to look beyond upfront costs and divide those costs over the lifetime of the battery. So that's why it's nice to have equipment with such a long warranty and even an expected lifespan beyond the warranty. So our batteries are guaranteed to have an end-of-life capacity at the end of the 10-year warranty to be at least 80% of the initial capacity still remaining. Similar with MidNite charge controllers, I've seen these things operate well beyond their warranted lifespan. Now, we do also have this LCOE cost calculator. This is great for finding the cost per kilowatt hour of your solution. I'll do a quick tour if it'll allow me. And I also wanted to just point out ancillary costs play a big role. So this is our equation here for the levelized cost of energy. But keep in mind, if you have to use a forklift or a crane to transport your battery into this site, that's going to be a big ancillary cost. Or, for example, with lead acid batteries, paying for maintenance and paying to have those batteries dragged out and replaced every 5 years, that is another added cost. So I'm just going to throw some numbers in here. I saw a quote for this amount on an invoice recently. We recommend 80% depth of discharge. And there you go. Almost 8 cents per kilowatt hour. Between 8 and 9 cents per kilowatt hour is really what I see for our batteries the most. Definitely depends on what distributor you get them from a little bit, but pricing is very similar across the board. You can compare this to other lithium batteries and even lead acid batteries to make sure you're getting the best value. So again, why use SimpliPhi batteries with MidNite products? Again, they're really reliable. We've both been in business for quite a while now, and I've seen many of our products operate well beyond their warranty lifespan with no issues. I genuinely have really never run into somebody complaining that a MidNite charge controller damaged their batteries or it's not working correctly. Really happy with their support over there as well. So thank you, Ryan, for an awesome product. And I wanted to also take this time to showcase the systems that I've seen from our IQ installers. So here on the left and right side, we have 2 systems installed by Greenwired. Now, Greenwired is in Redway, California. So that's north of San Francisco and south of Humboldt County. They are an IQ installer. They've got tons of experience doing off-grid systems, especially. And they've definitely become familiar with our batteries as well as MidNite's charge controllers and combiner boxes. And they also have installed several of these systems outdoors in cold weather as well. So they're able to build a nice insulated box and install heating pads to keep the batteries warm. If you want to check out Greenwired, if you need an installer, you can just click on their logos here and the link will take you there. Some more info on our IQ program. Wrapping up here is why become qualified. So as an installer, becoming IQ certified is basically going to give you a spot on this where to buy map. So as people are searching, let's say they're searching near Mount Shasta, California, they're going to see Greenwired is pretty close to them. And then they're going to click on this person to see who it is, and they'll see, oh, it's Greenwired, there's their phone number, website, and everything. This is where you're going to get a lot of leads from, as well as a feature that we can offer you in our IQ newsletter. These have been getting a ton of attention, and I just love this photo of this guy practically hanging off the roof installing some PV panels with great view. So this is our most recent featured installer, Derek Wadsworth, the owner of SolarWorks LLC. As a distributor, this is going to increase sales from your SimpliPhi installers and also highlight that you have better knowledge of our products and how to install them. Ultimately, we want to help you show distinction over other installers with our logo and branding. So if you're already installing our batteries, this is a no-brainer. It takes about 5 minutes to complete the application. You can click this link here to find it, and let us help you get some more exposure and promotion. So that's all I've got for today. Ryan and I are going to jump into the Q&A, but thank you again, Ryan, from MidNite Solar. Thank you so much for joining us today. And hopefully you guys all got a lot of learning out of this presentation. So I'm going to open up the Q&A. Ryan, are you able to see the questions as well?
I am, yes.
Perfect. All right, so let's see. 3.8 kilowatt hour, 48 volt batteries use a 54 volt float voltage. I would like a classic charge controller with hydro So once the PV charges your batteries to the absorbed voltage and then floats, will the classic keep the batteries properly at 54 volts after the sun sets?
Yeah. So if the classics are in what we call follow me, they will coordinate with each other and they will start a new day at basically midnight, or tomorrow. So after midnight, they will reset to a new day and start another bulk charge for the next day. But for that day, that particular day, yes, they would stay in float through the day. And if you wanted to go more than one day in float, you can also do what we call skip days, where, if you've got a system that rarely ever dips into the SimpliPhi battery, and SimpliPhi has suggested you don't absorb charge every day, we can do that every 5 days or every 10 days or whatever.
Perfect. Yeah, I really like the follow me mode. As you were explaining to me before this, it sounds like kind of all the other charge controllers go into float, and that can allow one charge controller to taper off those ending amps to make sure the battery gets nice and full.
Yeah, that is true. And that's important to use ending amps or return amps, whatever you may call it, depending on your history. And with the follow me, that works very elegantly with the Whiz-Bang Jr.
Agreed. So let's see. Another question about follow me, bolt off-grid system. They've got 3 classics in follow me: a Victron BMB 712 and 6 SimpliPhis. Testing voltage with a voltmeter yields a voltage reading about a quarter of a volt lower than the Victron BMB. What readings should the classics be calibrated to? Is that going to be the handheld voltage reading or the battery monitor voltage reading?
Yeah, so that's a good question. If you've got 2 devices whose sole job is to measure voltage and they disagree with each other, so if you've got a Fluke voltmeter, for example, and you've got a Victron battery volt monitor, and they disagree with each other, you're going to have to determine which one of those is inaccurate. And that's unfortunate to say, but you cannot really just assume that one or the other is correct. Generally speaking, a digital voltmeter is going to be very accurate, but it's definitely worth borrowing a friend's or getting another one. They can be had pretty inexpensively. And once you determine which one of those is inaccurate, then you would, calibrate to the one that you know is accurate.
Yep, definitely agree. Got to figure out who you're going to trust there. So that's a funny one. But let's see. To confirm, in an Outback Flex Power 2 with the FlexNet DC battery monitor, ending amps should be 0 or disabled, disabled in the FM80s. That is correct. So if you have the FlexNet DC, that's going to handle the ending amps in that scenario. And the charge controllers, you're going to want to set ending amps to 0 to kind of let them know that you have an FNDC. Are there breakers on the smaller batteries? Great question. I think you're talking about our 12 volt and 24 volt batteries. The 1.4 kilowatt hour, there is no breaker on those, but there is a built-in BMS.
MidNite Solar can trace back to Trace, you said? Yes, that is correct. So Robin Gudgel, the owner and founder of MidNite, was one of the lead engineers at Trace Engineering. He left Trace Engineering and started Outback Power Systems. Clyde left Trace and started Magnum Energy, and Magnum has since been sold, and most of the engineers from Magnum are now at MidNite as well. So, yeah, we've been in this for a while.
Sure have. For
the bus bars are what material? Yeah. The bus bars in all of our products are tin-plated copper, so they're actually copper.
Perfect. Let's see. What is preferred, wiring or bus bar? I really see very little difference here. It's just about what's going to make your installation easier. So if you've got, let's say, 40 batteries, you're going to want a bus bar so that you don't need 40 cables to be cut, crimped, and connected. If you've got 5 to 10 batteries, it's really just personal preference, and it really doesn't matter either way. I personally like to use cables because I can make it myself pretty cheaply and easily. And making bus bars can be a bit harder because I don't have access to a drill press right now. Do you have a link to normally use the heating pads? But yeah, for the heating pads, just shoot us an email. I think we use what we call hot start heating pads. We don't make them, it's just a heating pad that we've found that works very well. So if you're not able to find hot start heating pads, then just shoot us an email. Have you guys, I guess you guys probably don't really see a need for heating pads, Ryan, so you probably don't have any that you recommend specifically.
Yeah, no, we don't recommend anything there. We refer them back to you.
Yeah. Okay. So I have seen SimpliPhi 3.8 reaching absorbed voltage more quickly when the temperature in the room dropped to near freezing. How much temperature variation is there? That is a little confusing to me because there's really almost no difference in cold temperature. The batteries don't lose any capacity as the temperature gets colder. If it's truly 38 degrees Fahrenheit, then you really shouldn't see a difference. But if it's below freezing, then you'd want to stop charging, right? The batteries do not want to be charged below freezing. Yeah, I'm wondering if maybe your solar panels are producing more in clear and cold weather. They gain a little efficiency when it's cold, so maybe that's what's going on. I'm not quite sure there. FYI, 212 inch-pounds for the SimpliPhi 3.8 batteries as per info shipped with the batteries. Yeah, so the SimpliPhi, you can actually torque up to 212 inch-pounds if you want. However, 160 inch-pounds is just fine. So we're, simplifying our instructions. We're going to adjust that to 160 inch-pounds and also go up to 212 as Peter pointed out. Let's see. Moby said the combiner box is great for adding another battery to the system without shutting down. That's a great point, Moby. You don't even have to turn off your entire system to be able to add a battery to it when you have the combiner box. And I really appreciate you letting us use your photos. I almost forgot to point that out. We used Moby's installation photo. He was the one who had the 5 SimpliPhi batteries with the combiner box. Can I get a copy of this seminar for my electricians? Yeah, we're going to send out a copy to everybody who registered, so you'll all get a link to the YouTube recording. It might take a couple days to get out to you.
So you've got Joe with the combiner that has 250 amp rating and a battery of a 75 amp charge discharge limit. It looks like you can only put 3 batteries in MNLBC. 75 times 3 equals 225 amps. Joe, that's a very common statement that we hear a lot. And really, you want to base that on the load or the inverters / charge controllers, if you will. So, for example, if you had a single classic and a Magnum 100-watt inverter, you could put 10 SimpliPhi batteries on that. The inverter is only ever going to draw 4,400 watts, while the single classic is only ever going to charge at 84 amps. So the design of that is a little bit backwards. You kind of want to look at the loads and inverters and charge controllers to select your combiner box in that scenario.
Good point. Question from Rob. When installed last year, absorb setting recommendation was 54.4 for 1 hour. Now, the new integration guide shows 56 volts, but absorb time is 6 minutes. So just have the solar push the voltage to 56 and stop after just a few minutes. This seems to make the Whizbang Junior redundant. That's a good point. I think sometimes, in a lot of cases, the battery is not really reaching those end amps by the time the absorbed time limit is up. However, that's not always the case. Sometimes it does reach the end amps limit, so it's kind of an either or scenario. It's like, the charging can either be stopped by the timer or the absorb end amps. So either way, we just want to make sure that we don't overcharge the batteries, right? So undercharging the batteries, no big deal. You lose a tiny amount of capacity, but overcharging the batteries, you're going to damage them and permanently lose a little bit of capacity. So that's why it's really nice to have both built-in ways to end the charging, the timer and the ending amps. Whom do we contact for more training or perhaps design checking? You can contact training at simpliphipower.com, this email here, or sales@midnitesolar.com, depending on who you want to reach. We would be happy to check over your wiring diagrams. Let's see.
So the one from Robert, with any recommendations for use in a seasonal situation where systems are unattended September to May with sub-freezing temperatures. The only real concern there that we would have, I believe, would be charging the SimpliPhi below freezing. So one of the nice things that we will be doing moving forward very soon here on the Classic and all of our new charge controllers is allowing you to use that battery temperature sensor to monitor the temperature of the SimpliPhi, and we'll have a stop charge at a low temperature setting. So if the battery falls below, say, 32 degrees, we can use that temperature sensor to sense that and actually stop charging at that point until the battery warms up.
Yeah, that's going to be a big advantage. I like the sound of that because a lot of the current solutions that we're suggesting for cold weather are just to the batteries when they get cold. Now, that's awesome, but some people just don't want to invest in heating pads or hook all that up. So to me, it just seems a lot more simple to just not charge them when it gets below freezing, as long as that's going to be, a very rare scenario. For the Outback FXR inverters, you have 130 seconds as the delay for low battery cutout. I checked the firmware version of the inverters and they are current, but only allow 24 seconds max. Excuse me. Yeah, so if you actually program it to just 13 seconds on the inverter, it should show up. If you check your optics program, it should actually show up as 130 seconds. So I don't know if that's a glitch or if that's purposeful, but that's just what I've found, that you should just set it to 13 seconds on the mate.
And Moby asks if MidNite will have a firmware update on the older units to work with the temperature compensation, or I'm assuming he's talking about the stop charge below freezing temperature. And yes, that will be a future firmware update on the Classics. We're working on a whole list of updates that have been a long time coming on the Classic, and it will be factory in all the new 600-volt charge controllers hitting the market this year.
That's good news. Yeah, I saw those 600-volt charge controllers. Those are going to be awesome as well for people looking for bigger strings. Cool, Ryan. Well, thanks so much for joining me. And any last-minute things you wanted to mention?
No, I think that's it. Don't be afraid to reach out to MidNite at any time. Sales@midnitesolar.com gets directly to me. Pick up the phone and call us. The one beauty of MidNite is you can still call and talk to the owner of the company if you ask for him. So don't be afraid to reach out to us.
That's awesome. Yep. We're here as well, manning the phones. You can talk to me, so hopefully that's cool for you as well. But all right,
Yep.
thanks everybody
Yep.
for joining, and we'll see you next time.
Thank you.